So Tehani suggests they should fill in the data in the table in the following way. I notice that the function increases by the same factor each time. X goes up by 1, and I think this property should hold over each half interval as well. So fill in the parts of the table below that you have already computed in problem 1, and then decide how you might use Tehani's new strategy to fill in the missing data. As in the table in problem 1, each entry should be multiplied by some constant factor to get the next entry, and that factor should produce the same results as those already recorded in the table. Use this constant factor to complete the table. Also plot Tehani's data on the graph at the end of this task in problem 12. So, once again, 8, 16, 32, 64. But now we need a constant factor. When we were looking at Travis's, we just added them together, got 4 plus 8 is 12, divided by 2, and got 6. So we added 2 and then added 2. But Tehani's saying we need to have a constant factor. So if we start with 4, let's say 4 is our start value, and we're multiplying by a number once, twice. So we're multiplying by a number times itself, and that's going to equal 8. So 4 times the number squared, if we divide both sides by 4, we get n squared equals 8 divided by 4 is 2. So the square root of both sides, and we're left with n equals the square root of 2. So we need our factor, our action, is n equals multiplying by the square root of 2. So we have 4 times the square root of 2. So what would happen if we multiplied 4 times the square root of 2 times the square root of 2? The square root times the square root would equal 2. So this is really saying 4 times 2, which does equal 8. So that works out. So our action is times the square root of 2. Let's see how that looks in our next one, just to make sure. So in this case, we're starting with 8. We're multiplying by a number twice, a number squared, to get to 16. Divide both sides by 8, and n squared equals 16 divided by 8, which is 2, square root. So we're still multiplying by the square root of 2. This time it's 8 times the square root of 2. Okay. Then it says in the next problem, what if Tehani wanted to find the values for the function every third of the interval instead of every half? What constant factor would she use for every third of interval to be consistent with the function doubling x as increasing by 1? So in this case, when you get to the next problem, we're talking about starting with 4 to 8, but this time we have 1, 2, 3 jumps, and how does that change things?